Finishing up chapter 6, we're going to go back and talk about the area of a triangle again. We've already talked about finding the area of a triangle when you know two sides and the included angle. Often though, you're given three sides of a triangle and you want to find the area of that triangle. I'm going to derive the formula again, and I'm going to go through this pretty quick. If you don't get it, that's fine. It's mainly the formula at the end that you need to know. But as you know, I like to derive the formula. So we're going to start with the law of cosines by taking c squared equals a squared plus b squared minus 2ab times the cosine of gamma. And I'm going to solve this for the cosine of gamma, which means I need to subtract a squared, b squared from both sides and divide by negative 2ab, which would give me this. Again, the reason why the numerator values are positive a, positive b squared, and negative c squared is the fact that I'm dividing by that negative and I'm switching the signs in the numerator. I'm going to use the half angle formula for cosine, which you should remember is this. I'm going to square both sides to get rid of the square root. And then I'm going to take what I have from the law of cosines above and replace the cosine of gamma down here with this fraction. Okay, and it gives me the cosine squared of gamma over 2 is equal to 1 plus the fraction a squared plus b squared over minus c squared over 2ab, and that's all over 2. I'm going to get a common denominator in the numerator, so I'm going to multiply 1 by 2ab over 2ab, combine that as one fraction, multiply by the reciprocal of the denominator, would give me this. If you look at the first three terms in the numerator, that can be factored as a perfect square binomial, the quantity a plus b squared. Now, I have two terms here really. They're both squared, and there's a subtraction between the two, so that can be factored as a difference of two squares. It's a plus b plus c and a plus b minus c. And what I'm going to do is let 1/2 a plus b plus c equal s. Now think about what a plus b plus c is. They're all three sides in a triangle, so that's basically your perimeter. So I'm taking half of the perimeter and letting that equal s. So that 2s would equal a plus b plus c. So I'm going to replace a plus b plus c with 2s. So that gets replaced, and I get a 2s. That'll show up here in a minute. This is a plus b minus c, so I cannot replace it with 2s. But I'm going to cheat here a little bit. Inside this set of parentheses, I'm going to add a c, so I can replace it with 2s, and subtract a c at the same time. So I get a plus b plus c, and then minus 2 c's. This a plus b plus c then gets replaced with 2s. From here I can factor out a 2, which would give me a 4 out in front, which would cancel. And remember what this is equivalent to? The cosine squared of gamma over 2. Carrying that over to the next slide. To get rid of the square, I'm going to take the square root of both sides, which gives me that. And we'll stop at this point. That's one thing I will be referring back to in a minute. I'm going to actually repeat the same process with the half angle formula for sine. So here it is. The sine of gamma over 2 is equal to plus or minus the square root of 1 minus the cosine of gamma over 2. I'm going to square both sides, just like I did before, giving me this. Remember, the cosine of gamma was a squared plus b squared minus c squared over 2a. So I'm going to replace that right here, which gives me this. Common denominator again in the numerator. multiply by the reciprocal. This, you can see the grouping I have there, will factor as a minus b quantity squared, giving me a difference of two squares again. So it's going to be c plus the quantity a minus b and c minus the quantity a minus b. Distributing the negative here gives me this. Now remember, before we let 1/2 s equal a plus b plus c. So to create a plus b plus c in here, I'm going to add a b and subtract a b at the same time. And my second quantity, I'm going to add add an a and subtract an a at the same time. Which gives me this. And I remember 2s then was equal to a plus b plus c. So I'm going to replace this with 2s, this with 2s. Factor a 2 out from the first two, a 2 out from the second two, giving me a 4 out in front, which would cancel, and giving me the sine of gamma over 2 will equal this square root when I substitute it back in and take the square root. And I have these two formulas right here. Now we'll go back to the area of the triangle that we had before, which, if you remember, is the area of a triangle is equal to 1/2 the product of two sides times the sine of the angle between the two sides, so in this case gamma. Now notice, I can't do a direct replacement here because this is sine of gamma over 2, so I can't replace that. So what I'm going to end up doing is looking at the double angle formula for sine. The sine of 2 theta is equal to 2 times the sine of theta times the cosine of theta, but replace the theta with gamma over 2. So this theta is going to be gamma over 2, this theta is going to be gamma over 2, and this would be gamma over 2, but times this 2, the 2's would cancel, so the sine of gamma actually ends up being equal to this expression. Now that can be replaced in this formula for the sine of gamma, and then at this point the 1/2 and the 2 would cancel. The sine of gamma is what I have here up at the top of the screen on the left. The cosine of gamma over 2 is up here at the top of the screen on the right. So I'm going to replace those, which gives me this. Multiplying this out in the numerator gives me an a squared b squared on the bottom of my fraction. Underneath the square root, those squareds would come out as ab, which will cancel the ab that's out in front, leaving me with this. This is actually going to be your area formula when you know the three sides. It's called Heron's formula. Remember, S is 1/2 the perimeter. So the area is equal to the square root of 1/2 the perimeter times 1/2 the perimeter minus one of the sides times 1/2 the perimeter minus the another side times 1/2 the perimeter times the third side, or minus the third side. Okay, so here's Heron's formula again. Let's apply this to find the area of a triangle with sides measuring 3, 4, and 6. First thing I would want to find is S, half the perimeter. So if I add 3, 4, and 6, my perimeter is going to be 13, and if I divide that by 2, I get 13 halves. Now I'm just going to fill in S, A, and B, and C into this equation and simplify. So I get the area is equal to this. Running that through your TI-89 gives you the area is approximately 5.33 square inches. That is the end of this section on Heron's formula and finding the area of a triangle when you know three sides.